Now this is the lesson where we begin to step our game up and look at some slightly more advanced C# concepts. Today we'll be looking at arrays, what they are, how they work, and most importantly, how we can use them for audio implementation purposes. We'll then be looking at how we can tell our script to play a randomly chosen audio clip from a list that we give them. Not much more to say other than that, so let's jump straight into things. Let's start with the most obvious question: what are arrays? Well, so far we've been declaring and initializing all sorts of different variables. Those variables each held one single piece of information or data. Well, an array is a variable that can hold multiple pieces of data rather than just one. This allows us to create and store lots of data that we plan on using for the same purpose in a single place for us to access. So in concept, arrays are nice and easy, but creating an array variable inside one of your scripts is a little different from creating a regular variable. So in order to explain how it is done, as well as give you some more context as to how they work, we're going to break the process of creating an array into 3 simple steps. Step 1 is to declare the array. Okay, so let's say that we have a script called MyScript, and inside that script, we want to create an array of the string data type. Well, normally to create a regular string variable, we would declare it by writing the data type of the variable we would like to use, and then give it a name, such as word. Well, to declare an array, you simply do the exact same thing, but you also add 2 squared brackets at the end of the data type. These 2 brackets are almost like the symbols that represent arrays. So if you ever see a variable with them next to its data type, you'll know that that variable is also an array. Step 2 is to initialize the array. Now, normally the process of initializing a regular variable simply involves storing data inside of it. So with our word variable, we'd just add the equals operator followed by some string data to initialize it. However, an array variable first needs to know how many pieces of data it is going to hold before we can actually store anything inside of it. This is called the length, or the size of the array. The way we set the length is by first starting with the equals operator as normal, but following that, we have to write the keyword new, followed by the data type again, 2 squared brackets, and a number inside of them. Let's quickly break this down before we move on. The keyword new is required here in order for this to work. Now, thankfully, we don't need to worry about what it does too much in order to use it here. But to put it extremely simply, in case you're curious, we're telling Unity to make space for the data our array will hold inside the memory of whatever system our game is being played on, such as a PC, console, mobile phone, etc. The next part is the data type and number. By writing this, we're telling our array that we want to create a certain amount of space for data of this particular type. So in the case that you see on screen, we're telling our code to create 5 empty slots of space that we intend to store string data inside of. And of course, like any other variable that we declare and initialize, we need to end the line with a semicolon. Step 3 involves storing data inside those empty slots. Now, before we can do this, we need to understand what an index is. An index is a way of labeling or numbering a list or collection of data, such as data that is being stored inside of an array. Each piece of data is given a number to represent it, starting at 0. So the first piece of data is represented by 0, the second is represented by 1, the third by 2, and so on until we reach the end of our list. Now let's say that we wanted to store some words inside of our words array on the very first frame that our game ran on. Well, as always, we'd start ourselves off by writing inside of the start function. Now, when storing data inside of regular variables, we just need to write the name of the variable followed by the equals operator and the data that we wish to store inside of it. But for an array, we need to also tell our script which slot or empty space within our array we wish to store our data inside of. So let's say we want the first word in our array to be Pikachu. Well, we'd start off as we normally do by writing the name of our variable, which is words, but this time we also need to follow the name with 2 squared brackets. Then inside of those brackets, we need to write the slot number or index that we wish to store this word inside of. Remember that the first piece of data in an index is represented by the number 0. So to store the word Pikachu inside the first slot in our array, we need to put the number 0 here. Following that, we simply go through the same process as before. Write the equals operator and the piece of data we're storing inside inside of the array. We can then do this for the rest of the slots in our array. So to store a word in the second slot, we would do the same thing, but this time write 1 inside of the squared brackets instead. For the third slot, we'd write a 2. For the fourth slot, we'd put a 3, and so on until we'd filled up our array completely with data. Accessing particular pieces of data from our array also involves index numbers. Let's say that we wanted to use the debug.log function to display whichever word we stored inside of the third slot of our words array in the console tab of Unity. Well, inside the function, we'd write the name of the variable, which is words, followed by the 2 squared brackets. Inside the brackets, we'd write the index that represents the third slot, which would be the number 2. Then after saving our script and running our game, Unity would display that word for us inside of the console tab. Now, manually listing out the data that every slot in your array should contain like this isn't the most practical way or cleanest way to store data inside of an array. But hopefully this gives you a good understanding of how arrays work, as well as how they differ from normal variables. Okay, so now that we have an understanding of how arrays work, how might we use them to help us implement dynamic audio into our games? Well, in many games, there are going to be particular moments that happen multiple times as the player interacts with them. For example, if you're playing a first or third person game, you're obviously going to move a lot, and therefore, your player is going to take a lot of steps as you move about. Well, if these games were to play the exact same audio file over and over again every time this happens, the game would begin to sound very repetitive and obnoxious fast. So in order to make these moments sound more natural and to add a little variety to them, most games will often play a different audio file from a list each time these repetitive moments happen. So each footstep taken would trigger a different footstep sound to play, for example. With this in mind, the plan for this lesson is to create an array of audio clips for our tank shooting script that can hold more than one sound of the tank shooting. If we can create that, we can then tell our script to randomly choose a clip from that array each time a tank fires a shell. This is a very common practice with video game audio that I'm sure you'll get tons of use out of once you learn how to set this up yourself. So let's not waste any more time. To start, we once again need to make our way over to the complete tank prefab file in the prefabs folder. We can then find the tank shooting script attached to it as a component and open it up to edit it. Okay, so in the last lesson, you'll remember that we looked at the play one shot function and how we can use it to play a specific audio clip. Well, to give that function an audio clip, we created a public audio clip variable that we called clip. We then gave that variable a reference to an audio clip called shot firing. Well, just like how we can create an array of string data or integer data, we can also create an array of a reference data type such as the audio clip type. So what we're going to do is replace the clip variable with a new one. We're also going to scroll down to our script's fire function and temporarily remove the line where we triggered the play one shot function. Then let's scroll back to the top of our script. Okay, so in place of the clip variable that we've removed, we're going to create a public audio clip array, and we're going to call it clips. Now remember the 3 steps to creating an array. Step 1 is to declare the variable, which we've now done. Step 2 is to initialize it, and the way to do that is by setting the length of the array. So let's do that now. Let's add the equals operator after the name of our array and write the keyword new, and then write the data type we want to create empty spaces of data for, which is audio clip. After this, we write how many empty spaces we'd like to create for our array inside of 2 squared brackets. Now, we haven't yet checked how many audio clips we have inside this project that play a tank shooting sound. So for now, let's just set the length of this array to 3. Finally, the last step is to give our array some data to hold. Now, in the example we looked at earlier, we manually gave our string array data within the start function. But because our new array called clips requires audio clip data, we can't unfortunately just give the array the data we wish to from within our script. And this is why we made it public because one other way to give an array data is by using Unity's inspector tab, just like we can with regular variables. So let's save our script and jump back into Unity and give this array some audio clips to hold. Okay, so once you're back in Unity and your script has finished compiling, take another look at your tank shooting script attached to the complete tank prefab. You should now see the name of our clips array, as well as an arrow indicating a drop-down menu. If we click on the arrow, new fields appear that we can interact with. The first field, called size, tells us the length of our array and how many slots it has to hold data with. Remember, the size and length pretty much mean the same thing when it comes to arrays. They both refer to how big the array is, basically. Then underneath that, we have the 3 empty slots of our array that we can fill with data, labelled as elements. Notice how these elements start from 0. Again, these elements are labelled by index numbers. So the first is 0, the second is 1, and the third is 2. Now, before we can fill these elements with data, we need some additional audio clips to use for our tank shells being fired in our game. So if you take a look underneath this video, you'll see links to download 4 more audio files called Shot Firing 2 through 5. Download these files and import them into your project. I'll leave it to you to choose where in your project you're going to import and store them, as I've already imported mine. So once you've done that, make your way back over to the complete tank prefab and the tank shooting component. Once you're back and you've imported those files into your project, click on the small circle that sits to the right of the first element, element 0. So for the first clip, we're going to add our original shot firing audio clip. So once you've found it, go ahead and click on it. Now at the moment, we only have space in our array for 3 clips total. And we could go into our script and change this, but because it's public, we can also override the size of the array that we set in our script by changing the size field from 3 to 5. And by doing this, you'll see 2 more elements appear in your array. So now that we've grown our array to fit all of the shot firing audio clips, go through each element and add each clip to our empty elements. I'm going to go ahead and do the same myself. Great, so now our array is full of the many different shot firing clips. We can head back into our script and decide what we want to do with them. The last thing we have left to do is use our array to play the audio clips that it holds whenever our script runs the fire function. So let's scroll down to the fire function to bring the play one shot function back in order to play these clips with. We'll start the same way we did last time. At the bottom of our function, we'll write the name of the variable holding a reference to the audio source component attached to the complete tanks prefab, which of course is source. Using the dot operator, we'll call the play one shot function. Now we know that the play one shot function first requires an audio clip to play. Luckily, we've got more than enough stored inside of the clips variable. So we'll write that inside of the function's parameter brackets as its first argument. Don't forget to include the 2 squared brackets too, as we're going to need to tell our script which audio clip from our array we wanted to play using an index number. Now our goal, remember, is to tell our script to randomly choose a new audio clip from our array to play each time the fire function is called. So we don't want to just pick a number to give to our array. Instead, we're going to create a new integer variable which will hold a new index number for us each time the fire function is called. So let's call this new variable new index. Now we're going to declare this variable locally instead of globally for a couple of reasons. First, this variable won't be needed by any other functions in our script, only the fire function itself. Second, we won't need to hold any data after the fire function has been fully run. If this doesn't quite make sense to you yet, don't worry, it should make more sense once we give our new index variable something to do. So the new index variable is going to be given a random number to hold, which will then pass into our array and our play one shot function. How do we give a variable a random number? We use the random.range function, of course. So let's write equals random.range and add 2 parameter brackets. Now you'll remember back to the last module, we used this function to choose for us a random float number, which we also know obviously includes numbers with decimals. But here, we're using it to pick a random integer. So surely it shouldn't work here. They're two different data types, right? Well, thankfully, the Unity developers thought of this. Within the API of Unity lives a script and a class called random, as we know. Inside that script is a function called range, which is programmed to take two float values and output a random number that sits in between these two values. Well, there's also another function that's also called range. It is exactly the same as the first one, but this one is programmed for integer values instead of floats. So whenever we write random.range inside one of our scripts, Unity will recognize which one of these two functions we're referring to simply by checking whether or not we give it a float value or an integer value. This is something we can see too. If you hold Command if you're using a Mac or Control if you're using a PC and click on the random class name, Visual Studio should show you what the random class looks like. Now I'm going to quickly use the search tool to find the location of the two range functions inside of this class to show you. So whilst these functions look a little bit more complex than the ones we've been creating, you can in fact see that there are two functions called range. One uses float values and the other uses integer values. Being able to look into other scripts using Visual Studio like this could be a very powerful tool, by the way. Not only can you use it to learn about Unity's API like we're doing now, but you can also quickly look at other classes created by other developers of whichever game you might happen to be working on, such as our Tanks game. Now, if Visual Studio doesn't bring you to another script like it has done for me, let us know inside of our Discord group and we'll try and fix the issue for you. But I would say that your best bet is to first update Visual Studio itself, as that for me has fixed this issue in the past. I'll make sure to include resources underneath this video to help you to do that. But now that we've seen those two range functions, let's jump back into our script and finish writing it. Okay, so we know that in order for the range function to choose a random number, it needs a range. Remember that we want this function to pick for us a new index for which we can give to our array to tell it to select an audio clip with. Well, the lowest possible number in our index is going to be 0, as we know. So we can start by setting 0 as the minimum possible value. And we also know that our array consists of 5 audio clips in total. Because of that, you might think that we want to set our maximum value as 4, because the fifth piece of data inside of our array will be represented by the index of 4, right? Well, let's take a look at what just happened underneath our function. Visual Studio's IntelliSense feature will give us some information about the first of the two different range functions. This was also triggered right as we added the first of our two brackets after the function's name. We can now use the up and down arrows on our keyboard to scroll through the two functions and learn a little bit more about them. So let's press either the down or up arrow once to learn about how the range function that handles integer data works. Now it's a little bit small, but you should see some text underneath the function structure that reads, return a random number integer between min, brackets inclusive, and max, brackets exclusive. This text is trying to tell us that the range function will pick any number between its minimum, which is 0, and its maximum, which is 4. And in doing so, it will include the minimum number 0, but it won't include the maximum number, which is 4. Essentially, the highest possible number it will pick is 3. But of course, that means for us that the fifth audio clip in our array that is being represented as index number 4 will never be picked. So that means we need to set the maximum one value higher, which is 5. Now don't worry too much if Visual Studio did not display a message for you underneath your function. The main thing to take away here is that the maximum integer number used in the range function will not be included. Now what's interesting about this is that 5 is also the length of our array. So what we could do instead is give this function the length of our array as the max value. To do that, let's remove the number 5 and write the name of our array. This time without any squared brackets, but instead follow it with the dot operator so that we can access a public field called length. that all array variables provide for us. This makes things a lot easier for us because it saves us from having to change the max value of our range function if we were to ever change the length or size of our array. But anyway, now that our new index value will be given a random number between 0 and 4, we can finally feed it into the squared brackets next to the name of our array inside of the play one shot function. So now that randomly chosen number will be given to the clips array as an index for it to then return the audio clip represented by that index to our play one shot function to be played. Now we could end this by adding a second argument to the play one shot function to set the volume of whatever clip it plays, but I'm not going to do that myself, as remember it is optional. You can if you like. One thing I am going to do, however, is use the debug.log function just to display in my console tab which audio clip is being triggered by writing the name of our array and the index number representing the current audio clip. You don't have to do this yourself, but if for some reason you try testing your game and the tanks aren't playing different cannon shooting sounds each time, then writing this is a good way to start testing your script for issues. Once you've decided to do that or not, it's time to save the script and finally test it in Unity. Okay, so after saving my script, letting it compile, and finally saving my prefab, I've jumped straight into my game. Now let's see what happens if I fire a few shells from my tank. Amazing! Not only can we hear different audio clips being played, but we are also shown in the console tab the name of those clips. And with that, we now have a script that randomly selects different audio clips to play. Now there was a lot we were able to cover in this lesson. Arrays were obviously the main focus, but we learned how to not only declare and initialize them, but also learned a couple of different methods for storing data within them. Not only that, but we then used our own array to hold references to different audio clips. We also learned some little extras such as using Visual Studio to open scripts that are a part of Unity's API. Now I really hope you enjoyed that one because I promise you that you're going to find using arrays so helpful for audio implementation. In this lesson, the focus was clearly on choosing audio clips from an array randomly, but in the next lesson, we're going to look at some additional ways you can arrange the order in which your script chooses which audio clips from an array to play. So once you're comfortable with arrays, head on over to the next lesson.